So my video just cut out there. What happened was my hand just kind of went across my laptop and it minimized my camera and it stopped the video. That's all right. We'll just pick it up. Okay, so we came to, hey, there are no values of x where our second derivative does not exist. So we need to consider, hey, what's the domain of our original function? X to the fourth e to the negative x. Again, it's negative infinity to infinity. So we're going to mark those three criticals that we found on that number line, 0, 2, and 6. Just make sure they're in the right order, but they can be equally spaced. That's no problem. And now you see, hey, we've got a case where we actually had three criticals, so that makes 4 different intervals. So we got to plug in 4 different numbers, one from each. So I'm going to go ahead and pick -1, +1, 3, and 7. And if you're thinking, hey, where should you plug those in? How do I know which function? Is it the original? Is it the first derivative? Is it the second derivative? We're looking for concavity, right? So we got to plug these in to the second derivative. And let's just look at the first one here for the moment. Plugging into the second derivative. Why? Is it concave up or concave down? That means second derivative. So if I plug -1 in to the second derivative, right, 12 -1 squared e to the -1, oh boy, -8 -1 to the third e to the -1, plus -1 to the fourth e to the -1. That's my second derivative. When it's all said and done, right, that's 12e to the first, plus 8e to the first, plus 1e to the first. We'd have 21e to the first, or maybe just 21e. Now again, it doesn't matter what the number is. We're just looking for positive or negative. That's positive. Put a big plus sign right there. It's concave up. And if we do that for the other 3 intervals, we'll get these numbers here. So putting in 1 to the second derivative. When it's all said and done, you'll have 5e to the -1. Now the question becomes, is that positive or negative? It's positive. Now you can check in a calculator, or maybe you just notice, oh, 5e to the -1, that's 5 divided by e. That's a positive number. Okay. The 3 gives a negative, -27 e to the -3rd. That right there makes it, this is positive here, but of course that's negative. So that's less than 0, negative sign. And then for the 7, we go back to positive. And look at that. Positive, positive, negative, positive. Okay. So we are trying to answer 2 things here in the same question: intervals of concavity, and then we're going to do inflection points. But we can stop right here and we can answer the concavity just from our pluses and minuses. So I think that all fits on the screen. Oh, wow. Okay. It's concave up where we see a plus, -infinity to 0, union 0 to 2, union 6 to infinity. And it's only concave down in that one little interval from 2 to 6. Now at this point, a lot of times students will ask, hey, back over here with concave up, I noticed -infinity to 0, 0 to 2. Could we just say right here, -infinity to 2? No, because we're skipping 0 itself. This function is not concave up at 0, right? At 0, the second derivative was 0. It wasn't positive. So we have to skip 0 itself. It's concave up here. It's concave up here, but not there. So we got to skip that one number. Okay, so there's our concavity, intervals of concavity. Then the question said, okay, once you have those intervals of concavity, then identify any inflection points. If you remember, inflection points are when the function changes concavity. So if we look back, when did it change concavity? Well, not at 0 because it's positive to positive, but it does change at 2 and it does change at 6. So this is an inflection point. Sometimes you see that abbreviation IP. Okay. So I've got it all down here, squeezed in to this page. So what we're going to do, we know the x coordinates of the inflection points, but it's a point, right? An ordered pair. So we want to know the y coordinates. So where do we plug the 2 and the 6 in? To the original function, because we want to know y values. So the original function was x to the 4th e to the negative x. So plugging in the 2, you'll end up with 16 e to the negative 2. You can just leave it like that. Don't bother rounding. I like this. How about the 6? Well, 6 to the 4th is 1,296 e to the negative 6. So those are inflection points. 2, 16 e to the negative 2, and 6, 1296 e to the negative 6. We've got a little bit more to talk about. I'm going to save it for its own video after this one.